My calendar says this is episode 50.
Ah, the big 50.
Yeah.
What's that called? Is that a half centennial? It's not a bicentennial.
I don't know. Hey everybody, and welcome to episode 50 of the iPhreaks show. This week on our panel we have Andrew Madsen.
Hi from Salt Lake City.
James Zuber.
For the 50th episode, I've got balloons everywhere. You can't see it because of podcast, but they're there.
There you go. Pete Hodgson.
Good morning from the city that knows how.
I'm Charles Max Wood from devchat.tv, and this week we're going to talk about web APIs with your iOS app. This is something that I'm particularly interested in since I tend to do more of the web API end of things as opposed to the Objective-C iPhone app end of things. So I can complain about some of the stuff that people do just because I know it's wrong, and you guys can also talk about some of the stuff that people do that you wish they didn't. Maybe I'll learn something.
So it's kind of interesting, just before the call, someone, I can't remember who said it, said something about talking to the server team. James had something about how to talk to your server team. And Chuck, you just kind of touched on that as well, kind of like, oh, there's things that, you know, the server team wish that the iOS guys would do, and there's things that the iOS guys, the client-side team, wish that the server-side guys would do. So this is an interesting application of this thing called Conway's Law. Have you guys ever heard of Conway's Law?
Yeah, the structure of the program will basically imitate the communication structure of the team or teams that are working on it.
Yeah, exactly. That's a much better description than I normally come up with. I always struggle to describe it. So I always think this is really interesting, right? Like if your server team have a hard time, if your back-end guys don't have a good communication channel with your front-end guys, then your back-end code tends to not have a good communication channel with your front-end code.
Yeah, I have to say that typically on the teams that I've worked on that we've had to expose an API for, whether it's like a front-end JavaScript or an iOS app, usually what happens is the back-end or the front-end team will say something to the effect of, we need an API that gives us this, and then the back-end team will go implement it and then tell them where it is. Does that more or less reflect your experience, or have you seen it work other ways?
Well, so I've got experience with a few different things, and it depends on the type of the organization. I've worked in like little startup environments where there isn't a server team and a front-end team. There's just the team, and they tend to be oriented more around functionality. So you might have the photo browsing team, and they're responsible for the photo browsing capabilities of the app, and that encompasses like the back-end stuff and the front-end stuff. And that's kind of, again, that's like applying Conway's Law or wielding Conway's Law to make you more effective. So if you shape the team vertically, then you tend to have like really good, efficient communication across the stack in terms of the team, which means you tend to have good, efficient communication across the stack in terms of the actual APIs you build.
So when you're saying your team is organized vertically, what does that mean? Yeah,
sorry, that's I guess if I had a whiteboard, I would draw a layer cake. So there's that kind of that classic kind of layer cake that people draw of like, this is our database tier, and this is our back-end or middle tier, and then this is our client-side tier or something like that. So you normally draw these kind of horizontal kind of rectangles. So when I say vertically oriented teams, I mean they're kind of like, if you imagine you've got these kind of layer cake rectangles, the team kind of slices vertically through the entire stack. So it owns the front end that relates to that functionality, plus the back end, plus the database maybe.
Okay, so you're working with people that understand what's happening in the database, what's happening on the web service, and understand what, you know, the client iOS portion is.
Yeah, okay. and a lot of times that will also be, there'll be some Android guys and some iOS guys working on the same team, like cats and dogs. And a lot of times when I tell people that, they don't believe me. It's like, that's not possible. Oil and water, they cannot mix. But yeah, I've worked on teams that have done that, and I actually think it's pretty effective if you can pull it off.
Do you ever run into problems with that kind of setup between the different teams needing similar functionality or sharing functionality?
Sometimes what you have is that you kind of have these vertically aligned teams, and then you kind of have either some other kind of support team that goes across the top that implements kind of common things, so like more infrastructure-y technical stuff. The other thing that I've seen, or I've heard of working pretty well, I haven't actually seen it myself, is this model that Spotify talk about a lot, where they have teams that are grouped around functionality, but then they have these kind of communities of practice or tribes, I think they call them, where like, I might be the database guy for the photo browsing team, and that's my team. That's like the guys I work with every day, the guys and gals I work with every day. But I'm also part of like the database kind of community of practice. So I'll get together on a regular basis with my database buddies, and we'll talk about like the problems that we've been solving in the photo browsing thing, and some other person from the login team will describe how they're building some new caching thing that everyone else might be interested in using, that kind of. I mean, it's definitely, I'm sure there's a risk there that you end up reinventing the wheel, but I think it's a good trade-off in exchange for not having super ineffective, I mean, I think everyone's had that experience of being where you have like the server team build some API that doesn't work very well, and then you want them to change it, but they don't have time because they're working on something for some other team. You lose so much efficiency that way. I feel like it's actually better to just orient yourselves vertically and do things that way.
Yeah, one thing that I'm a little curious about with that, though, is that do you make up the team then of people who have the database skills and the back-end server skills and the front-end server skills? Or do you kind of make everybody learn, to some degree anyway, all the different parts?
Yeah. So I think it's a bit of both. It's kind of like, I mean, I think we already do this a lot with, nowadays we do this a lot with like database stuff, right? It used to be, old school app development was like there was a DBA department and database administrator department, and like if you needed to get anywhere near the database, let alone write a query, let alone insert anything into the database, just write a query that was touching the database, you had to go to this separate team and describe your requirements, and then they'd build something and throw it over the wall to you, and you'd say, oh, that's not quite right, and you'd throw it over the wall back to them, which sounds really kind of clunky and antiquated, but that was the same kind of thing we're talking about with front end and back end. And now what tends to happen, I think, with most teams is you have the teams are responsible for doing database stuff. There tends to be one person on the team who happens to be more interested or more capable on, writing efficient SQL statements or tuning indexes or whatever. So he or she will tend to be the person who's like the expert in the team and who ends up writing a lot of those stories that are kind of database focused. And, you can translate this to iOS, be like the person who's really good at core animation or the person who's really good at core data tends to do a lot of those kind of bits of work. So they're like the expert, but it doesn't mean that they're the only person that's allowed to work on the story. Mm-hmm. And they also might have, again, going back to this community of practice thing, they might have connections to experts on other teams who can help out in a pinch. So if there's some super gnarly core animation thing, for example, they'll kind of reach out to their core animation community of practice and say, hey, I can't get this thing up to 60 frames a second. Can you guys help me with this CA layer issue or whatever? I don't know. It's a very, very long-winded way of saying, I think, yes, you need like a poly-skilled team, but it doesn't mean every individual on the team needs to be an expert on everything. And it also doesn't mean that you have to have all of those skills in the team. You can also reach out to kind of support people if you need to.
So I like the idea that you're talking about, like a vertical team where people have kind of your data server and kind of client people on the same team. One challenge I run into where if you're doing something kind of agile, sprint-based, you do 1 week, 2 week sprints, and you say, okay, we're going to do this feature this sprint. And your server team gets to work, and the client team doesn't have anything to test with or even wire up until, halfway through the sprint or near the end of the sprint. So how do you deal with those type of challenges?
So that's actually something I was going to touch on earlier was this idea of like, so Chuck, you said something about you kind of, the server-side team build you this API, and then like, it's not quite right, and then you kind of go through this period of like, well, they decide what the API should look like, and then they give it to you. There's this approach called consumer-driven contracts, also kind of sometimes called contract testing. And the idea there is the team that's going to be consuming this API. So in our example here, it would be the iOS team or the front-end team or whatever. They actually define that API in terms of tests that describe like what the API could do. So it's kind of like using behavior-driven development. Well, it is using behavior-driven development, but rather than describing the UI and saying, when I click on this thing, this error message should be displayed, or like when I log in, but my credit is expired, then I should be told my credit's expired. You're instead saying, when I send this chunk of JSON to the server, then I expect this chunk of JSON to be returned. So that's one way of doing it. It's a pretty extreme approach. Like, I think most people would be pretty skeptical that it can work, but I've seen it work. And it actually works really well when you've got those disconnected teams, because it's a way for you to communicate with code, like, unambiguously, rather than kind of communicating via wiki pages or like Excel spreadsheets describing the API.
Yeah, one other thing that occurs to me is that if you follow some sort of standard across the team or across all the teams, for example, we're going to use REST, and we're going to do this or that, for the things that don't fall neatly under however we define or understand REST. That makes things a lot simpler, too, because the back-end team can move ahead knowing that they're probably going to get something similar to what the front-end team is going to request, and it streamlines a lot of that communication. So, you can actually write test harnesses that basically implement the tests around REST, and then that saves the front-end team time in specifying the APIs, and the back-end team can also use standard libraries to do that on the other end.
Yeah, and there's a few like standards that are emerging out there for JSON, for RESTful JSON APIs. So there's this standard called HAL, or this spec called HAL. There's another one called Siren. There's a few of them out there that kind of like just define how you, like a kind of a common way of structuring JSON APIs. And I think that really helps because you can build like client-side libraries around it and server-side libraries around it. I don't know if there are any for iOS, but there definitely are in other languages kind of standard consumers for things like HAL and Siren.
So, Pete, before we get into stuff like HAL and like Siren, I'm not familiar with Siren, but I understand HAL. Generally, we should probably define what we're talking about when we talk about REST. I mean, it could be anything from having kind of resource-based web servers to going, kind of a more hypermedia approach, Hades, hypertext as the engine of application state. Can we talk a little bit about that? Like what the difference is? When people say REST, it's kind of a conflated term. You're not sure what they're actually talking about.
Yeah, REST is kind of like
basic stuff.
It's like Web 2.0 back in the day, right? It doesn't actually mean anything at this point, I think. Or like DevOps. It's a term that has been so overused it now doesn't mean much at all. It means not SOAP. And sometimes it means not XML, although you can do XML. So my definition of REST, so there's a guy called Sam, I think it's like Sam Richardson, I think, who wrote this really good book, RESTful Web Services, I think it's called. I'll have to find the book and post it in the show notes. But so he described these like levels of maturity. So the basic form of REST that I think most people kind of agree on is this idea that you're posting and or you're sending and receiving kind of documents, like JSON-based documents, using URIs, so using some kind of like shared document structure against kind of known URIs. So that's like the basic stuff. So that's sometimes called POX or POJ, like plain old XML or plain old JavaScript or plain old JSON. Sorry. And then I wish I should actually look up these levels because I'm trying to remember what they are, but I'm not actually getting right. But basically, that's the basic stuff, and that's what a lot of people call REST. A lot of people who are like REST dorks, RESTafarians, yeah, kind of get really upset when people call this stuff REST because it's not really REST, right? According to them. So the next level up from that is you start using the different HTTP. I think this is the next level up, but if I get it wrong, then it's not like I'm being recorded on a podcast or anything.
Yeah, no one will complain.
Yeah. So if I remember correctly, the next level up from that is using the verbs that are in HTTP and using them kind of semantically. So when you get something, it shouldn't have any effects on the thing that you're getting. So if I do a get on like /user/Pete, then that shouldn't modify that resource, that kind of thing. Now that sounds kind of obvious, but there's loads of APIs out there where like you do like get /user/Pete ? Change password equals new password or something. That violates a bunch of stuff that the web assumes is going to happen, and it means that you lose a lot of really nice things that REST gives you, like caching and the ability to retry requests without worrying about them.
Yeah, I don't think that's obvious at all. If you haven't been doing kind of this type of development for a while, I think a lot of us, we're doing object-oriented programming. We're used to calling methods into objects. And one of the things that they talk about in that book is that's how we started doing web services. We'd call a method on a web service, and that's how we would distribute things around. So that's just how everyone did it. Said, go do this on this web service. So it's pretty it's a very different mindset than kind of what they're talking about with RESTful. Kind of reusing kind of the architecture of the web, the HTTP stuff, saying, okay, don't call a bunch of methods on this object. This is a resource, and one of the things we can do, we can get it. But Git will not modify that at all. So you can call Git 20 times, it's not going to modify what you're actually doing.
Yeah, and I guess you're right. I've been doing REST-based stuff for long enough that I kind of forget how it is. There is this whole other mindset that a lot of people are used to of like essentially the web as like a big remote procedure call kind of thing, right? Where you're calling a method on an object, it just happens to be somewhere else, not next to you.
So, I had to go through that book at least twice before I started to actually kind of get it.
Yeah. Yes, I think it's definitely true, right? Like this idea of thinking of, I guess maybe a catchy way of describing it is REST is about nouns rather than verbs. So in OO, we're very used to thinking of, or in programming in general, we're very used to thinking about things in terms of actions that we're taking. So log in or change password. With REST, the way you get the real kind of value out of building a REST-based API is by flipping your thinking. So rather than focusing on the actions, you're focusing on the resources, the things that you're acting upon. So your primary thing is the user, and then maybe you might be changing the password on the user, but fundamentally you're acting upon the user. You're not performing an action, you're performing an action against a resource, a known kind of entity.
Okay, we talked a little bit about like kind of the get, that's one of the HTTP verbs. But you're talking about something that changes kind of the state, like a password. So you have like a user resource, so you do a get, which would get you your information. How do we actually change the password? How does that work?
I think with all things REST-based, it depends on how dogmatic and kind of Restafarian you want to be about it. So the way that I would do this with most things is with a post. So a post is basically the sledgehammer of HTTP. You can use it for everything. It doesn't have any semantics, so you don't have, like the thing I was saying with get, where you have, or the thing that you touched on as well, where get you can get something 500 times and you'll always get the same result, assuming nothing's changed elsewhere in the system. Post doesn't have any of those rules. You can do whatever you want with a post. All bets are off. You're allowed to do whatever you want. So that makes it really useful. It also means that it doesn't have as much value because all the stuff in the middle doesn't know whether you're changing something or not. So you lose some benefits from using something like post, but post is the sledgehammer that you can use for all this kind of stuff. So you could say, you could have like a resource /users/Pete, and then if you wanted to change the password, you could just post the new password to /users/Pete/change password, for example. So probably some REST people are freaking out right now because I'm not using the right verb, but I'm a lot more pragmatic in my Restafarianism than dogmatic, I guess.
Yeah, it's a good point to remember that, if you need to call like a method on an external object and that old kind of thinking, they generally do it with a post. Yeah. So if you wanted to call a change password and post that, that's the way you do that kind of things.
Yeah. The other two verbs that are there that would be another option is put and patch. So put, so you can think of post as kind of do anything, but generally it means change something. Put is like update all the things. So let's say if I wanted to update user/Pete, so I wanted to change my mailing address. One way that I could model that is I get that resource, so I do a get on /user/Pete. I get like the whole representation of that user in JSON form or whatever, and then I modify the things I want to change, so the email address or the password or whatever, and then I put that entire JSON, chunk of JSON, that document, that thing that represents that user, I put it back to the same URL. So that's the other way of doing it. Now, the problem is you don't get to just put, with a put, you don't get to say just put the password. If I just put the password, then I'd essentially be saying delete everything else about this user and it's like an overwrite, right? It's not like a updating in place. It's like overwriting whatever's in that current resource. And the nice thing about that is because you're specifying the whole state of the resource, you can send a put, and if you're not sure if it went through or not, you can just send it again. Because you're not specifying a change, you're specifying the new state of the world. So the really obvious kind of example here that helps explain it is with this post versus put thing is, let's say I'm modeling bank accounts. So this is the old hackneyed example, and I've got a balance on my bank account. If I was taking $20 from Chuck and giving $20 to Pete, I might model that by sending a post to Chuck saying debit the account by $20 and then sending a post to Pete saying credit the account by $20. Now, if I send that post and I'm not sure if it goes through or not, what do I do? If I'm not sure it went through, but it actually did go through, and I send it again, then I've given Pete $20 more than it was supposed to. And, so you get all these problems of not knowing whether an operation completed or not, because that post isn't idempotent. You can't do it multiple times and have the same effect. If instead, rather than saying, give Pete $20, you said, Pete's current balance is $80, so set his current balance to $100 using a put. If that put fails, I just send it again, because it's idempotent. I can do the same thing over and over again and have the same effect. So that's a big benefit of using something like put over something like post.
And so you also mentioned patch?
Yeah, and then so patch gets around this. The problem that I mentioned earlier was that if I want to modify one field of my account or the user or whatever, I have to download the whole object or the whole resource and then modify the that JSON and then send the whole thing back up because I'm overwriting the whole record, the whole resource. Patch is like that, but it's like a update in place rather than overwrite everything. So I can just send the fields I want to update, and it kind of makes a patch, kind of like a patch in source control. It just modifies the stuff that's specified. So if I send a patch that just says my username, it just says my email address and my password, and no other fields, it will change those fields in the resource, but it won't change any of the other fields. So that's a way you can avoid having to download everything and then re-upload it again.
So that's very cool. I remember a couple of years ago when I was looking at this same problem where you'd have a big entity and we just wanted to change one thing. All the Rastafarians said, hey, do patch. I looked at the client libraries, and support was at least spotty, at least back then. Most client libraries are going to give you a git, put, post, that type of stuff. How's the library support for patch?
So I actually have no idea. So it's interesting with this, with the Rails world. For a long time when folks were first doing REST in Rails, even the put wasn't really very well supported. And the way that they got around that with Rails was kind of basically doing a post with this special magical indicator that said, hey, this is really a put. Even if your library doesn't support patch, you can do the same thing, and you're still getting most of the value. The Rastafarians will scream at you because you're not honoring the one true way of whatever. But if patch isn't available, or you're not sure it's going to be available, just use post and use some kind of scheme to indicate that what you're doing is actually a patch. You lose some of the benefits. So all of the systems in between don't know that you're actually doing a patch. So you lose some kind of semantics that the systems in between can use for caching and stuff like that. But at the end of the day, it's not that big a deal, to be honest. I don't think it's a big deal anyway. I'm not an expert I'm not a total REST expert, so maybe I'm missing some huge issue. But I think even if it's not available in your library, then you can kind of simulate it kind of in your code.
Yeah, well, and then the other thing, REST initially was based off of a paper it was a PhD thesis by somebody.
Fielding. Roy Fielding, yeah.
And apparently what we understand as REST, especially in the Rails world, because Rails coined their own sort of thing of REST, it doesn't quite match up with that. And that's where hypermedia APIs come in. And so there are a lot of different ways of following a standard for doing this kind of thing. And it really just depends on what your preferences are and what the trade-offs are and how well you understand them.
Yeah. And that last piece, that hypermedia, is that final level. So that's like when you kind of reach the nirvana and you kind of suddenly realize, it's like in the Matrix when suddenly you realize it's all code. It's all hyperlinks. Everything. It's just hyperlinks.
No.
Yeah.
So let's talk about hypermedia. I think we talked about, you mentioned the term REST itself is overloaded, even though that's what Fielding meant is kind of the highest level of what RESTful is. That's in current practice, it's kind of just using HTTP verbs.
Yeah.
But hypermedia is something all different. Let's talk about kind of what's the difference between a kind of RESTful HTTP approach and doing hypermedia. What's the difference?
So I think that I give a lot of credit to some folks in the kind of current REST community. I think Steve Klabnik has been one of the guys doing this, that they've basically embraced the fact that REST doesn't mean what they want it to mean. So they've made up a new word that means what REST used to mean. So hypermedia APIs is what we used to call REST APIs, as far as I can tell. So what's hypermedia? So when you go to Amazon.com and you want to search for books in a certain category, you don't go up to the browser and go like /?, books equals whatever. You just go to the homepage, the root of Amazon, and Amazon gives you a bunch of options of like, here's things you can do. There's this form here where you can fill it in, and if you send me a query string in this form, then I will do a search for you. So hypermedia is kind of like that, where instead of me, the client, going to the browser and going, okay, I want to look at the phishing books section, so I'm going to go up to the browser and type /phishing. Instead, I start a root resource and I just follow links to get to where I want to go. And the key thing here, the big difference, it seems really stupid, and I think most people, when they first start doing this, they think it's silly and ineffective or inefficient and just something that people do because it's trendy. But the big change it makes in your API is your client no longer has a bunch of hard-coded kind of dependencies on the server. The server's deciding what the client can do, and that means that your server can evolve the API over time without your client having to move in lockstep with the server.
So the difference is, if I'm understanding you, so I'm going to Amazon, I'm clicking on something, or my API is going to the service where I'm looking for phishing books, and I don't get back a bunch of information on phishing books. I get back a bunch of links. Is that right?
Yeah. So let's say you'd go to the root of your API, and what you'd get back is a bunch of links, and like part of that response would be like, here's all the different departments in the bookstore, and here's the names of those departments, and here's the URL to get to the list of books in that department. And so rather than the client creating their own URL and then kind of just going to the server and saying, hey, I want /books/phishing, it asks the server to kind of describe what links are available to it, and then it looks through those links for the one it wants, and then it follows those links. So it seems like kind of the same thing, but the difference is the client isn't deciding the shape of the links or the structure of the resource space, if you want to get all fancy about it.
Okay, so like before I'd say, okay, give me a list of books, and then I'd get the book I want to look at the ID, and then I'd go books/ID/whatever and get that.
Yeah.
But in this case, I'm actually getting a link, and I just say, oh, I pass this link to my NS URL collection, and I get the data that I want without having to specify what the URL is.
Yes.
Mm-hmm.
Very cool.
It seems, I don't know if this, I was just thinking a little bit about documentation, which I hope we talk about, but it seems like that design is also easier to figure out if you're just new to the API.
Yeah, that's a really...
Because it's sort of self-documenting, right?
Yeah, that's a really good point. Has anyone ever worked with an API that's an internal API that's documented on a wiki where the wiki documentation was actually correct? Like, didn't have any stale like things in it. It never is true, right? The documentation in general gets out of date eventually, but API documentation, it seems like it's never ever correct, and it just gets worse over time. So I think that's one of the real benefits of this kind of hypermedia thing is this self-documenting APIs.
Yeah, and you don't need to write code to see what the API is doing. You can go to a browser, hit the resource, copy and paste the links if it's just JSON, and say, okay, I'm going to this state. I'm going to this state. Oh, this just broke, and so I can paste whatever links and not have to write any code and anyone can run it. It's easy to write tests around. You do some scripty type tests. So it's easy to kind of tell your server team what happened if you broke something.
Yeah. And if you're using like one of these standards like HAL or Siren, you can actually get this kind of generic HAL browser, for example, that you can like load up. It's a little JavaScript app that you load up in your browser, and it will kind of let you follow these links in with quite a nice UI. You're not like, searching through JSON and copying and pasting links. You're just like, it's pretty similar to actually browsing a website. Oh, except obviously it's machine oriented, so it's not going to be like pretty or have like, super verbose names, or maybe it will. But I've seen people use those kind of things to actually do QA on an API, for example.
So how is a HAL response different than the standard web service response?
It's just like a convention for putting in your links, basically. So I'm more familiar with HAL than the other ones, but I think most of them are pretty much the same. So if you're not doing hypermedia, then there's no real benefit of using HAL, because you're just basically sending a chunk of text or a chunk of JSON or XML or whatever down to your client, and then the client is doing something specific with that to pull out the IDs and form the URIs or whatever. But once you get to the point where you want the client to be able to follow links, then you need like a convention for what those links are going to look like. So HAL basically just gives you a convention of saying all the links will be in this subsection of the JSON document called _links, and there will be a set of names. Each of those will have like a name and then an href, so a URL. And it also lets you do templating. So there's this standard called URI templates, which lets the server say to do let's say you want to do a search for the weather for a city. You could say you want the server to tell the client how to do that search. So if the server just says, the search thing is on /weather/city, then the client doesn't know how to use that to do a search. You can't list a link for every single city because that would be ridiculous. You'd have this 500 megabyte JSON document with a link to every city. Instead, what you do is you say, here's the template for building a URI to search for the weather in a city. So you say, the template would be /weather/city, and then in curly brackets, $city equals whatever. And then the client can use that template to say, okay, I just plug in the city search string here in this URI, and that's how I do a search for weather in a city.
Okay, so we talked about one aspect of the response has something for links, and it's underscore links. What about the data I actually want to look at? Is it all links, or could we actually have data that we can actually use?
So one of the things I really like about HAL is it's very, very lightweight. So if it's just data, so going back to my user example, if you're trying to do a representation for /users/Pete, the first name, last name, email address, all that stuff, you can just throw that into JSON any which way you want, just like you would if you weren't doing HAL. So regular fields just go in as regular fields. You don't have to do anything special there at all. Links go in this special subsection called _links. And then there's also this concept of kind of embedded resources. So you're asking the server for a list of all the users' friends. So you want to get friends of Pete. So actually that might be a good worked example to work through how this would work. So I might go, after the client has logged in, it might go to the server and do a get on /users/current user, or it might just be /current user. The server says, okay, you want to know the canonical resource for the current user, so I'm going to redirect you to /users/Pete because that's the person currently logged in. So now the client has pulled down the JSON that represents /users/Pete, and in there's a link called friends, and that goes to /users/Pete/friends. So now the client, your iOS app, follows that link, and it gets back a list of all the friends of Pete. So in this case, the client has not specified any of those URLs. It's just following a set of links that the server got back, or that the server sent back to it. So at this point, it's got the client has pulled down /users/Pete/friends, and what you want to see is a list of those friends, and you want to know their name and their avatar or whatever, so you can display it in the app. So you can think of each of those friends as another user resource, and essentially you want to embed a set of resources inside of this response. So it's not just one user; it's 7 users. So HAL lets you do this thing called embedded, just _embedded, so that you can tell the client this isn't just a list of stuff. This is actually each of these individual items is its own resource. It has its own URL, but you can actually return all of that data in one document rather than making the client kind of say, okay, here's a list of 50 URLs, and now I have to go and pull down the URL for /user/Chuck, the URL for /user/James, etc.
So if we get a list of Pete's friends, and we'll say those are embedded, do you generally have the entire information for the friends? Is it a subset of things?
That's a good question. So I know that there's definitely an option there of doing what I kind of call abridged resources. So you don't want to send down the entire resource. If it was 50 users, it'd be quite inefficient maybe to send down everything about every user if all that you really care about is their name and a link for more information. So you can do that. You can just send down the entire thing, or you could, I guess, just send down links. So that's the ultimate version of the abridged resource would just be, instead of sending down the actual resource, you just send down a bunch of links so that if the client wants to, they can follow that link to get the full information about that person. I actually don't know whether HAL has any conventions around that, but I know that when I've done this kind of stuff before, I've definitely reached for those kind of ideas of abridged resources. So you send down just enough so that you can display on the client a list of all the users with their name and a photo, for example. But then if you need more information, then when the user taps on that user, then you'd go and follow the URL that came with that resource to get the full information about the resource.
Yeah, I've also done it, though, the other way where, let's say I have a dashboard or some page that displays multiple pieces of information. Rather than make the canonical request and then make the other request to get the other information, when working with an API like this, I've also set up an endpoint that's basically like get dashboard info or something. So then I make the request and I get all of the information back because I know I need it for that page. And, I can kind of tailor it to the behavior that I have and not have to make multiple requests to get everything I need.
Right. That's going off of the REST topic for a second. That's a really good example of what I would expect to see more of in a vertically aligned team. Particularly, if it's a team where you're the team, right? You're doing the server side and you're doing the client side. You can build that API to work with the client. So if the client doesn't want to make if the client is always going to make the same 5 requests for the same 5 pieces of information, just make an extra endpoint that represents all of that information bundled up. It'll be more efficient. It'll be less load on the server, et cetera, et cetera. If the client and the server teams aren't able to work together well enough, then they end up not doing that. And so because the communication between those teams isn't very efficient, the API that they design isn't very efficient, and it ends up like having to do a bunch of extra work.
Yeah, I think the other danger with a lot of this stuff is that we tend to think of our resources in the same way we think of our database tables, and that doesn't always line up with what's the most efficient way to build our API.
Yeah. I think that's when you've reached the point that the way that you model your API doesn't map directly to the way that your database is laid out. I think you're in a really good spot from like a resource modeling, like a REST point of view. If you've kind of grokked that and you can kind of project the data into a different form so that it can be consumed better by clients, then I think at that point you can kind of say that you understand how REST works.
Okay, so you're saying that, REST doesn't just have to be CRUD over your database, and it probably shouldn't be. All right.
It's a good start. It's better to do that than it to just be like basically modeling method calls. But I do think there's this kind of level that you go there's kind of evolution you go through where you start off with method calls and then you kind of turn it into essentially CRUD over your database. And then you suddenly kind of have this revelation that like you can model these abstract concepts as resources. You can kind of reify the concept of logging in as a resource, even though there isn't a login table in your database necessarily.
Okay. Yeah, that's very cool. So one thing I wanted to ask, people on the show, we've got some good back-end people, we got some good client people, we got people that do both. Do you think that a mobile app should generally reuse the API from like the main website?
What do you mean? So like for like the JavaScript front end?
Yeah, a lot of times, like a mobile app will do some subset of what the main website would do. You have some web application, the mobile app will do not everything. It's going to do like some small piece of it. So we talked a little bit about kind of HTTP. You do a put. Okay, so I get the user Pete, and I know about these fields. The mobile app may not know about every single field that might exist from the website. So you have problems where you get a put from a mobile client, which maybe doesn't know everything, where like the full application would have a bunch of different fields that the mobile app doesn't really care about. So how do you manage that type of thing?
So mainly, let me talk a little bit about the way I tend to design my APIs, and that is that if somebody doesn't need it, I'm not going to expose it. So let's say that we have like a full-on web application, we have a little app we've built called Facebook or something. And, we want to build an iPhone app that does a lot of the things that Facebook does. Well, I'm not going to build those APIs until I know somebody out there needs them. And so in this case, if I'm only exposing APIs for my private application, then I'm only going to build them as the iPhone app team needs them. That way I don't have to maintain anything that's not being used. And I don't have anything sitting out there that could be a potential security vulnerability if I don't upgrade it. And so usually APIs in the apps that I build are not as fully featured as the actual app, unless for some reason things haven't moved ahead on the web app and they have on the iPhone app to the point where they're basically reaching feature parity.
Okay, so you generally have a different API for kind of the web application and the mobile client?
So as far as having an API that's separate for both, that really depends on what I'm trying to accomplish. One of the tricks between the two is that typically on the web, your authentication can be different from the authentication from a device. The flip side is that if you're using something like OAuth or something, then you can store the OAuth tokens in the cookies or somewhere where the browser can get them. And that way your JavaScript is then capable of making the API requests using the OAuth tokens that we're talking about. And then your mobile app can do the same thing. And then you just make sure that those tokens expire after a reasonable amount of time for security reasons. But, then you kind of can. The other thing you have to keep in mind, though, is if the behavior between the two is different enough, then you may wind up exposing different APIs. The flip side is then you wind up maintaining a surface area that's sort of, to some degree, at least twice as large as the other. So as much as you can make them overlap, you'll get the payoff there. But it's not always simple because the capabilities and requirements aren't always the same.
Right, yeah, that's something to figure out. You got the trade-off. One hand, you're re-implementing a large part of the application for a mobile or a full web app when maybe you don't need to. But yeah, it's good to get some perspective on what people are doing, because I've had problems with both approaches, so it's always good to hear what people are doing.
Yeah, I'm not convinced that there's a direct right answer to that, but if you know enough about what you're trying to do and enough about the systems that are accessing it, then you can make decisions based on the trade-offs that are there.
Okay, very cool. So are there any other benefits to doing this kind of RESTful approach?
Quite funny you should ask. So one of the things that I've found really, really valuable with this REST-y stuff, not necessarily all the way up to hypermedia, but at least kind of embracing the nouns and that kind of thing is, treating things as nouns rather than verbs, is caching. So the web is like one of the most, it's probably the largest distributed system in the world. And it works pretty well considering how crappy most of the stuff is out there. Like, servers go down and things have slow response times and yada, yada, yada. And a big reason for why the web manages to scale so massively is that it has a bunch of kind of caching infrastructure built into it. So if you also do kind of browser-based development, if you do any kind of front-end kind of JavaScript or that kind of stuff, then you probably know, or even if you do web development in general, actually, then you know about kind of the way that browsers can really be intelligent about caching stuff that hasn't changed. So there's all these kind of caching kind of headers and pragmas that you can use. So the server can say, this response is valid for the next 10 minutes, or this response is valid until this date, or you can use things like e-tags, which are ways for the server to say, here's a tag that represents the state of this object. If next time you ask me, if the tag is the same as last time, then you don't need to re-download it, just use the thing that you have cached locally.
So by caching, what benefit do we gain from caching? How does that even work?
There's a few things. I mean, the cheapest network request is the one you never send, right? So if you set up your NSURL connection or whatever to honor the caching information that's returned from the server, and you set up your server to actually send caching information, then you can do things like let's say you have a news feed that only updates once a minute, and on the server side, that it's not going to change more frequently than once a minute. What you can do is when the client kind of makes a request and says, hey, give me the latest from the news feed, when the server responds, it can say, hey, in a caching header, it can say, this isn't going to change for a minute, so don't even bother to ask me for another minute. And then the next time the client wants that news feed data, if the cached copy is still fresh based on that information, it cannot make the network call at all.
Okay, so
obviously that's a huge win.
So you're making a call your network request, but it's not actually going out to the network. It's just returning what is cached locally on your device.
Yes, exactly. Okay. And what's really cool there's two really cool things about this if you do it at the HTTP level. Number one, your client code doesn't need to do anything at all. Your client code can happily do what looks like really inefficient operations, like making a URL request every single time, but it's never going to go out on the wire. It might not even go to disk. It might just go to memory. So you get like this kind of free caching on the client side if you do the work on the server side. And then the second benefit is the server, which knows the most about the state of this data, gets to decide how to cache it, and it can change that over time. So if in the future you decide, let's say, so this is kind of maybe a little bit of a convoluted example, but let's say your service is undergoing like a bunch of extra load, and you've got, suddenly you've been featured on the front page of Hacker News. Loads of people have downloaded your app, and they're all hitting the news feed, and you're realizing that you just can't scale to the number of users, and you want to dial back the freshness of the newsfeed to be only 5 minutes versus 1 minute. If you're doing HTTP caching headers, then you can just change that on the server, and all of the clients will start honoring that straight away. So that means like you don't need to release a software update, you don't need to do anything at all, you just need to change the caching stuff on the server, and stuff just magically works, right? So it's and that makes sense to me. It makes sense to put the control for the cacheability of something in the hands of the server, because the server knows like whether something's changed or not and how frequently it's changing, way more than an individual client does.
Do we have to do anything on the client side to kind of honor the caching stuff?
You have to kind of tell iOS to use caching. I can't remember if it's by default or not anymore. I remember you might need to do some extra stuff to ask it to use a separate store or something like that, or it uses a separate store by default. I can't remember. I'm pretty sure iOS does a pretty good job of just doing this for you, as long as you're using, as long as you're not like writing your own network layer, which I don't think anyone's really doing.
Caching is really powerful. I mean, if you think, like, no matter how complex your server operations are, you make a request, do a bunch of crazy database stuff, and process stuff in memory, and you spit it back. Whatever you spit back is generally just a text file. And that's something that, almost every web server can dish out, very cheaply. So you can do a ton of it without having to go back and forth your database and web server and that kind of stuff. So
and there's all this stuff in the middle, which we don't really think about that often, but is actually particularly relevant for mobile. So when I make a request for some resource, so, the newsfeed or whatever, there's a bunch of intermediary caches that might get hit. So the carrier, AT&T, for example, probably has a cache where they're trying to cache like very, very commonly used or commonly requested resources. Someone might be using Akamai or other edge caching technologies to kind of try and keep the content physically closer to you so that you don't have to go all the way back to the UK or Australia or whatever for the content. Once you get into the server's infrastructure, they might have like a caching layer in front of their application server, etc., etc., etc. And if you use HTTP caching, then you get to leverage all other people's caches for free. So you get to, not just do you get the free caching on your phone, but you get free caching with Akamai, you get free caching with whatever caching the network provider is giving you.
So it sounds like you get a ton of stuff thrown in if you just play by the rules of the web and make your gets idempotent so they don't change.
Yeah. And that, a big thing for that, this one weird trick to improve your caching is don't use query parameters on gets unless you have to. Because, I guess back to what we were saying at the start of the show, so many people for so long were used to kind of making gets that actually did stuff. Generally, the way that people have always done that is to do like question mark, change password equals new password or whatever. Even though you're doing a get, you're actually changing things. You can't cache that, because if you cached it, then the next time you tried to change the password wouldn't get changed, right? So by definition, that kind of operation always has to get all the way back to the origin server because it's changing something on the origin server. Now, because so many people abused this functionality and did like the wrong thing, it's now built into almost every caching technology that they'll ignore. They won't cache a get with a question mark, even though in theory they should. So if you put a question mark in there, then you're like breaking the cacheability of your resources.
That's true to a point. I know with IIS on the Windows side, you can actually cache different query parameters. You can explicitly say, "I want to cache this one." You're saying that?
It's true with it could be true with the technology that you own, but it might not be true with like Akamai, for example. So Akamai might have some hard, and you can probably tell Akamai, "Hey, please, even though this has a query parameter, please turn off the magical thing," whatever. But I definitely have heard at least anecdotally that putting query parameters into your URLs where you don't need them, it hurts the cacheability of those URLs.
Okay, sounds like even though it may be possible to do more caching with query parameters, if you're trying to do it, you're probably doing it wrong.
Yeah. Although, there's some stuff that you kind of need to use query parameters. Search is like the obvious example, right? Like, you can't have every single search query in the world under a URL. You can, but it's just really weird to do that, and the semantics kind of don't make sense. So modeling that with query parameters makes a lot more sense, I think.
All right. Is there anything else that we should cover on this? We've been talking for an hour.
I kind of wanted to talk about faking out backend services, but I don't think we've got time to do it justice, so maybe we'll have to save that for another show.
Yeah. Is it a topic that we could cover in an entire show?
If you let me talk, then yes.
Okay, good enough. We'll get it on the schedule.
Put it in the queue.
Yep. All right, well, we'll wrap up then and do the picks. James, do you want to start us off with the picks?
Yeah, I'll start off with the picks. So I probably would have made two of the picks that Pete's going to make, so I'm not going to steal his picks. I'm going to pass on them. I think I made picks the last time we talked about hypermedia, but I'm going to talk about a grain. It's not specifically a beer pick, but I like rye as a grain. It grows kind of north of here. A lot of beer makers are starting to make beer with rye, and I like it a lot. It's kind of nice and spicy, but you don't have to just have rye and beer. I've made like cereal, had my pressure cooker out, put rye with oats and stuff. It's pretty good. Makes good bread. It's just an all-around good grain. I think that should get more props. So I'm going to just pick rye. And specifically, the local brewery around here, Summit, has made a Frostline rye ale, and it's actually pretty nice. So I've been enjoying quite a few of those lately. So that's probably the next thing in brewing, you know. Everyone's getting over quadruple IPAs, but now they're all doing rye beers. So check them out.
That's one.
All right. Pete, what are your picks?
Back in the saddle. The Rye Pale Ale from iPhreaks. I have picked it before, but I don't care. I'm going to pick it again. RESTful Web Services was the original book that I really liked from a few years ago. RESTful Web APIs is the new one that he just released recently, which I've heard is very good. And this paper by these guys that are at Spotify called Scaling Agile at Spotify. And that talks a lot about vertical teams and this kind of ideas of community of practices and tribes and guilds and all sorts of crazy concepts. If you're skeptical about this whole vertical teams thing, then you should read this paper at least and then disagree with me.
All right. Andrew, what are your picks?
So the first one is just a post by Justin Williams on his blog from a couple weeks ago that I really liked, that kind of summed up my feelings on using third-party libraries. In iOS apps, I think people who know me know that I'm not super enthusiastic about using lots of third-party libraries in my apps, and this, he kind of has the same feelings I do, so I thought that was a good post. And then the other two are sort of music picks. The first is a pair of speakers that I recently bought that are really cheap. Amazon's got them for $87 right now, and they're made by Pioneer, but they sound super, super nice for $87 speakers, and so I've been very happy with them. And then lastly is Discogs. Discogs is a website that has discographies for, I think the goal is to have all music ever released on any format in any country. They're not there yet, but it's open, sort of like Wikipedia. You can submit and edit the information there yourself, and they let you build up a list of all the music in your collection, and you can do buying and selling. And anyway, it's just been, I'm a record collector, so it's a great resource, and I've been enjoying adding my stuff to it lately. Those are my picks.
Awesome. So I'm trying to think of a few picks. One thing that I've been playing a little bit of lately is Diablo 3. I know the game's been around for a while, but I needed something to kind of break up the heads down coding time a little bit. That's been kind of fun, so I'll get on and play it for a half hour here or there just to kind of clear my head and relax a little bit. Another pick that I have, and this is a tool that the team that I've been working with for the last week is using, is called Flowdoc, and it's kind of a team chat deal, and you have different, I think they call them flows or contexts, but basically you can reply to somebody else's post, and it'll go into its own little stream. And so you wind up having two panes, and one pane is like all of the conversations in the same thread, and then the other one, if you click on the little bubble next to the message that somebody sent, then it'll actually show you the context that they're speaking in, and you can reply to just that context. So anyway, it's pretty nice, and so I've been able to get help that way, and people can carry on other conversations in other contexts, and it works out pretty nicely. And so I'm pretty happy with that. So those are my picks. I also want to remind everybody we're reading the Functional Reactive Programming book. We were going to do that this week, but there was a technical, or he had some family emergency and couldn't make it this week. So we rescheduled that, and we'll be talking to Ash a little bit later about the book. So keep an eye out for that. And thanks for listening. We'll catch you all next week. Hosting and bandwidth provided by the Blue Box Group. Check them out at bluebox.net. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.